Hello, everybody. So we're going to talk about some exponential growth and decay that happen in the real world. So these applications are like this. There's the money that grows with interest. So you start with some amount of money, and then each year or each month or whatever your time period would be, it increases a little bit. The bank gives you a little bit of money back, or your stocks grow in value, or whatever. And then this new value grows a little bit, and that grows a little bit, and pretty soon you have a nice sum of money. Also, populations grow by reproducing. So you have a couple, and then they have a baby, and this happens throughout the whole population. So if all the couples are having a baby, then it's growing by a certain amount. Then the babies have babies, and the next generation has more, and so on. But also populations decay, or they go down due to death if they're not reproducing at a higher rate. So you have, it may be cut in half if half the people die. Yes, I have a broken heart there. And then, then the next generation, half the people die, and the next half the people die. So that a population could go down. Radioactive materials decay by radioactive decay. And so you have a piece of uranium, and then over time it has what's called a half-life, and it decays into another element, like lead, for example. So there's less uranium around. Pressure decreases the higher you go in altitude. So at sea level, it has a certain pressure, and then as you go up, it increases in or decreases in pressure rather, the higher that you go. So let's do a problem here with money and kind of see how this works. So if we start with $1,000 and it grows by 10% interest per year, so we're going to have $1,000 plus, we're going to add on 10%. So 1,000 times 10% as a decimal is 0.1. Okay, and then we get our value at the end of the year. So 0.1 just moves the decimal place over one space, so that makes 1,000 into 100. So this is going to be 100 plus 1,000, so 1,100 will be the new value. So now you have this new amount of money, 1,100, and it's going to grow again by 10%. Okay, so I would move the decimal point over again and get 110. So 110 plus 1,100 would be 1,210, right? So you can see that from here to here, it didn't just grow by 100, like this one grew by 100, right? But this one grew by 110, so it grew by a larger amount. So let's continue that. So now we have 1,210 plus 1,210 times 10%. So move the decimal place over 1 and you get 121. So 1,200 plus 121 would be 133 and 1. Right. Yeah. Okay, so this is the new amount, and then it happens again. And you see this pattern kind of developing, that every time I'm kind of taking the previous amount, and so the previous amount goes here, goes here, goes here, and here, right? So this would be 231 plus 133.1, right? So 1, 4, 6, 4, 1. So 14.64 and 10 cents, right? And it would go on in this pattern continuously, but I want to find out, like, so this is the first year, right? First year, second year, third. So I want to see, what it is in year N. So if I had any number of years, what would it be? So I can take advantage of this pattern that seems to be appearing, and instead of using the numbers, let me use variables. How about placeholders? So A this would be A plus A times 0.1 equals B, right? And then it's B plus B times 0.1 equals C, and then C plus C times 0.1 equals D. So can you see what I can do here? This would be D plus D times 0.1 equals E, right? But I could rearrange this to say, I could say, well, this is D times 1, right? And this is D times 0.1. So I could change it to this, right? This is equivalent. And then I could factor this out, right? Using the distributive property, kind of undistribute this. So I say D times 1 plus 0.1, right? Equals E. And now you can see that I could have done that in every case, right? I could have factored out this number on the front and just had 1 plus 0.1. And then it'd be 1 plus 0.1, right? Let's think about this. So this is 1,100 times 1.1. And then I take this value and I plug it into the, which was 2010. So this is actually equal to 1,000 times 1.1. And this is actually equal to 1,000 times 1.1. And then I multiplied that value times 1.1 again. Right? And then I multiplied this value times 1.1 again. So you can see that each time I'm multiplying by 1.1. So my pattern is 1.1 times 1.1 times 1.1. What is repeatedly multiplying by the same number? Well, that's exponentiation. You just repeatedly multiply by the same number. So this would be 1.1 to the n power equals my final value, right? Okay, so let's just do one for fun. Let's see. Let's say you put $1,000 in the bank. You got 10% interest. That's pretty good, actually. Maybe you were saying stocks at this point. So you invested some stocks that had a good return of 10% per year over this long period. So let's say 30 years. So what would it be? 1,001, or no, just 1,000 is what you start with. It's 1.1 to the 30th. And let's pull the calculator out and see what it gets. Okay, 1,000 times 1.1 to the 30th. See, that's a nice little chunk of money. So 17,450. So that'd be pretty great if you could get that return. 30 years, so you made $16,000. So that's what they mean by when they say it takes money to make money, right?